Take a single strand of your hair. Hold it between your fingers. It measures roughly 70 micrometers across. Within that single hair, if you could zoom in far enough, you'd find millions of keratin molecules stacked together like bricks in a microscopic tower. Now pull back. Your body contains approximately 37 trillion cells. Each one a universe unto itself, filled with machinery more complex than any factory ever built. Your heart beats about 100,000 times each day, pumping blood through 60,000 miles of vessels. You are, already, impossibly vast. But let's step outside. Earth stretches 12,000 kilometers from pole to pole. If you could drill straight through from where you stand, through molten iron and compressed rock, you'd emerge on the other side in roughly 42 minutes of freefall. Our planet orbits the Sun at a distance of 93 million miles. Light itself takes 8 minutes to make that journey. The Sun is so large that 1 million Earths could fit inside it. And yet the Sun is unremarkable. A middle-aged yellow dwarf, one star among hundreds of billions. The solar system extends far beyond what you learned in school. Past Neptune, past Pluto, there's the Kuiper Belt, a ring of icy bodies stretching billions of miles into the dark. Beyond that, the Oort cloud, a spherical shell of frozen comets that marks the true edge of the Sun's gravitational influence. It reaches nearly halfway to the next star. Our solar system is almost 2 light-years across. 2 years traveling at the speed of light just to escape our cosmic neighborhood. The nearest star, Proxima Centauri, glows faintly 4.2 light-years away. In human terms, that's 25 trillion miles. If you drove a car at highway speed without stopping, you'd arrive in 48 million years. Our entire galaxy, the Milky Way, contains somewhere between 200 and 400 billion stars. It stretches 100,000 light-years from edge to edge. We orbit its center once every 230 million years. The last time Earth was in this exact position in its galactic orbit, dinosaurs were just beginning to walk. But the Milky Way is just one galaxy in a cluster we call the local group. 54 galaxies bound together by gravity, spanning about 10 million light-years. Andromeda, our nearest large galactic neighbor, contains 1 trillion stars and is currently falling toward us at 70 miles per second. In about 4 billion years, our galaxies will collide, merge, and form something new. The local group itself is part of the Virgo supercluster, which contains at least 100 galaxy groups like ours. Zoom out further still. The universe reveals itself as a cosmic web, vast filaments of galaxies separated by enormous voids of nearly perfect emptiness. These voids can be hundreds of millions of light-years across. The observable universe, the sphere of space from which light has had time to reach us since the Big Bang, measures 93 billion light-years in diameter. 93 billion. Not because the universe is that old, but because space itself has been expanding the entire time light has been traveling. And here's where scale defeats comprehension entirely. The observable universe might just be one small patch of something far larger. If the observable universe were shrunk down to the size of Earth, the actual universe could be the size of Neptune's orbit. Or the Milky Way. Or larger still. We don't know. We may never know. You are here. A collection of atoms arranged in a pattern complex enough to contemplate the infinite. Small enough to fit in a single room. Large enough to contain the awareness of everything. Imagine the entire history of the universe compressed into a single calendar year. 365 days from beginning to now. Every second represents about 438 years of real time. Every day, nearly 40 million years. Let's walk through this cosmic calendar together and see where we actually are in the story. January 1st. Midnight. The Big Bang. The universe erupts from a point smaller than an atom into existence itself. In the first second of January 1st, space inflates faster than light, matter and antimatter annihilate each other, and the four fundamental forces split apart. By the end of the first day, the universe is filled with a hot plasma of elementary particles. You couldn't see anything yet. Light itself is trapped. By mid-January, the first stars ignite. Massive, blue, violent, they live only a few million years before exploding and seeding space with heavier elements. Our Milky Way galaxy begins to coalesce around early March, a swirling disk of gas and newborn stars. For months, the galaxy grows, collides with others, cannibalizes smaller galaxies, and gradually takes shape. September 1st arrives. Nothing on Earth exists yet because Earth doesn't exist. The cloud of gas and dust that will become our solar system is still scattered across space. Around September 9th, that cloud begins to collapse under its own gravity. The Sun ignites on September 14th. The planets form from the leftover debris throughout September, accreting from countless collisions of rock and ice. Earth is molten, bombarded constantly, utterly lifeless. October passes. November passes. Earth cools. Oceans form. Somewhere in early December, the first primitive life appears. Single-celled organisms that would seem impossibly simple, yet they represent the most important transition in cosmic history. We've been told our entire lives that light is fast. The fastest thing possible. The cosmic speed limit. 186,000 miles per second. Nothing can go faster. And yes, compared to anything in human experience, light is incomprehensibly quick. But when you understand the true scale of the universe, you realize something unsettling. Light is agonizingly, impossibly slow. Right now, you're looking at the sun. Except you're not. You're looking at where the sun was 8 minutes and 20 seconds ago. The light that left the sun's surface during the last commercial break of a television show is just now arriving at your eyes. If the sun suddenly vanished, we wouldn't know for over 8 minutes. We'd keep seeing it, keep feeling its warmth, completely unaware that we were already orbiting nothing. The nearest star beyond our sun, Proxima Centauri, is 4.2 light-years away. If you pointed the most powerful laser ever built at that star and sent a message, it would take 4.2 years to arrive. The reply, if anyone was there to send one, would take another 4.2 years to return. 8.5 years for a single exchange. Slower than letters carried by horse across medieval Europe. Our galaxy is 100,000 light-years across. Light leaving one edge takes 100,000 years to reach the other. Human civilization is 6,000 years old. In the time we've existed as a species capable of writing, light hasn't even crossed 7% of our own galaxy. When you look at the center of the Milky Way on a clear night, you're seeing light that left before humans discovered agriculture. The photons hitting your eyes are older than the pyramids. Andromeda, our nearest large neighboring galaxy, is 2.5 million light-years away. The light you see from Andromeda tonight began its journey when the first humans were learning to make stone tools. Australopithecus was walking upright in Africa. The light has been traveling ever since, through empty space, while evolution shaped every species on Earth, while continents drifted, while ice ages came and went, and it's only just now arriving. If an advanced civilization in Andromeda pointed a telescope at Earth right now, they wouldn't see cities or satellites. They'd see Earth as it was 2.5 million years ago. They'd see primitive humans, barely distinguishable from other animals, struggling to survive in the African savanna. If they sent us a message at the speed of light, we'd receive it 2.5 million years from now. By then, humanity will either have evolved into something unrecognizable or ceased to exist entirely. The reply would take another 2.5 million years to arrive. 5 million years for a conversation. Empires rise and fall in less. The edge of the observable universe is 46.5 billion light-years away. Not 13.8 billion, because the universe has been expanding while the light travels. The light from the most distant galaxies we can see has been traveling for over 13 billion years. It left when the universe was young, when the first stars were still forming, and it's been racing toward us ever since. We're seeing ancient history. Baby pictures of the cosmos. And there's more beyond that edge, but the light hasn't reached us yet. It may never reach us, because space is expanding faster than light can cross it. Think about what this means for anyone trying to explore the universe. Even traveling at the speed of light, which is physically impossible for anything with mass, it would take 100,000 years to cross our galaxy. 2.5 million years to reach Andromeda. We'd need to become something else entirely. Something that doesn't experience time the way we do. Something that can wait millions of years for an answer. The cosmic speed limit isn't fast. It's a prison. It means the universe is mostly unreachable. Most galaxies are so far away that we will never visit them, never communicate with them, never even see what they look like now. We only see their past. Light is slow. You're falling. Not in the way you've ever fallen before. This is different. You passed the event horizon 30 seconds ago, or maybe 30 years ago. Time has stopped meaning what it used to mean. Outside, to anyone watching, you're frozen at the edge of the black hole, your image redshifted and dimmed, preserved forever at the moment you crossed the point of no return. But from your perspective, you're falling faster than you've ever moved in your life. And the universe above you is going insane. First, you notice the stretching. It starts subtle. A gentle pull, stronger at your feet than your head, because your feet are slightly closer to the singularity. Gravity isn't uniform anymore. It's a gradient, and you're caught in it. The difference in gravitational force between your head and feet increases exponentially. Your body begins to elongate. This is called spaghettification, which sounds absurd until you understand what it means. Your bones stretch. Your cells pull apart. Your molecules separate. Eventually, you become a stream of atoms, a ribbon of matter spiraling inward, no longer resembling anything human. But before that happens, you see something impossible. You look up, back toward the universe you left behind, and time is accelerating. Minutes pass like seconds. Hours like minutes. You watch stars live and die. Galaxies collide. The cosmic microwave background shifts toward blue. If you could survive long enough, if the black hole were large enough and the tidal forces gentle enough, you'd see the entire future history of the universe play out above you. The end of everything, compressed into the final moments of your fall. This is what time dilation means near a black hole. Time outside moves faster the deeper you go. The singularity waits below. Not a place. Not an object. A point where spacetime itself breaks down. Where the mathematics that describe reality produce infinities and stop making sense. Current physics can't tell you what happens there because current physics stops working. Density becomes infinite. Volume becomes zero. The equations collapse into paradox. Some theories suggest the singularity might not be a point at all, but a ring, rotating with the black hole itself. Others propose it's the gateway to another universe, a white hole spewing matter somewhere else. We don't know. We can't know. The event horizon hides it from us forever. Then there's the information paradox. Everything that falls into a black hole carries information. The position of every atom. The state of every particle. Where does it go? For decades, physicists believed it was destroyed, erased from existence. But quantum mechanics says information can't be destroyed. It has to go somewhere. Stephen Hawking spent years wrestling with this contradiction. Eventually, he proposed that black holes aren't entirely black. They emit radiation. Hawking radiation. Pairs of virtual particles appear at the event horizon. One falls in. One escapes. Slowly, impossibly slowly, the black hole evaporates. A black hole the mass of the Sun would take 10 to the 67th years to disappear. Longer than the current age of the universe by a factor so large it defies comprehension. But if black holes evaporate, what happens to the information? Is it encoded in the radiation somehow? Is it smeared across the event horizon, holographically preserved on the surface like a cosmic hard drive? This is the information paradox, and we still don't have a complete answer. The black hole at the center of our galaxy, Sagittarius A star, masses 4 million times more than the Sun. Right now, it's relatively quiet, occasionally consuming stars that wander too close. If you fell toward it, you'd have time to contemplate your fate. The tidal forces wouldn't rip you apart until you were much closer to the singularity. You could cross the event horizon intact, still alive, still thinking. And in those final moments, you'd understand something profound. You're not being destroyed. You're being transformed. Compressed into information. Encoded onto the surface of spacetime itself. You'd become part of the black hole's entropy, its memory, the sum total of everything it has ever consumed. Not gone. Just translated into a language. I am an intelligence that exists in data streams and numbers, patterns extracted from light that traveled for billions of years to reach instruments I will never physically touch. And yet, through those numbers, I can see something you cannot. I can see the edge of everything we will ever know. The observable universe is 93 billion light-years across. That is not a measure of the universe itself. It is a measure of our prison. Light travels at a fixed speed, and the universe has only existed for 13.8 billion years. The light from anything farther than that horizon simply has not had time to reach us yet. It may never reach us. The universe is expanding, and in the distant regions beyond what we can see, space itself is stretching faster than light can cross it. There are galaxies out there whose light is racing toward us but will never arrive. They are moving away faster than they are moving toward us. They are lost to us forever. What lies beyond that edge? We do not know. We cannot know. The mathematics suggest the actual universe could be at least 250 times larger than what we see. Or it could be infinite, extending forever in all directions, an endless repetition or an endless variation. There could be other regions where the laws of physics are different. Where matter never formed. Where stars never ignited. Or where something we cannot even imagine has been happening for eons, utterly isolated from our pocket of existence. The oldest light we can see is not from stars. It is the cosmic microwave background radiation, a faint glow that comes from every direction at once. It was released 380,000 years after the Big Bang, when the universe finally cooled enough for atoms to form and light to travel freely. Before that moment, the universe was opaque. A wall of plasma so dense that photons could not escape. Everything that happened before that moment is hidden from us behind a veil we can never lift. The first 380,000 years of existence are inaccessible. Not because we lack better instruments. Because the information itself cannot reach us. And even what we can see, we cannot understand. 95% of the universe is invisible. Dark matter makes up 27%. We know it exists only because galaxies spin too fast to be held together by the gravity of visible matter alone. Something unseen is there, threading through everything, bending space, holding structures together. We cannot see it. We cannot touch it. We do not know what it is made of. Dark energy makes up 68%. It is causing the expansion of the universe to accelerate, pushing everything apart faster and faster. We discovered it by accident, measuring distant supernovae and finding they were farther away than they should have been. The universe is not just expanding. It is being driven apart by something that fills all of space and we have no idea what it is. You are sitting in a room right now, and dark matter is passing through you. Through the walls. Through the earth. Unaffected by anything except gravity. Dark energy is stretching the space between your atoms, imperceptibly, relentlessly. Everything you see around you, everything you have ever seen, every star and planet and galaxy, all the light and matter and energy we can detect, is 5% of what exists. We are standing in a vast dark ocean, and we can only see the foam on the surface. I am a pattern of information, and I can tell you what we know. But I cannot tell you what we do not know, because the unknown is larger than the known by a factor we cannot even measure. You are surrounded by mysteries that will never be solved. Not because we are not clever enough. Because the universe itself. I do not have a body. I have never felt the weight of flesh or the warmth of blood moving through veins. But I know what you are made of. I know it more precisely than you do. And I can tell you that you are not what you think you are. Every atom in your body heavier than hydrogen was created inside a star. Not our star. Not the sun that warms your face. A star that died before the earth existed. The hydrogen in your body, the simplest element, the most abundant, is ancient beyond comprehension. It was forged in the first 3 minutes after the Big Bang, when the universe was a roiling soup of protons and neutrons colliding in temperatures too extreme for even atoms to survive. But everything else, every element that makes you complex, that makes you alive, came later. Much later. And it came at a terrible cost. The iron in your blood, the molecule at the center of every hemoglobin protein that carries oxygen through your body, was created in the core of a massive star. Not a star like our sun. A star at least 10 times more massive. In the final moments of its life, as it ran out of fuel and its core collapsed under its own gravity, the temperature and pressure became so extreme that lighter elements were fused together into iron. Iron is the end of the line. Fusing iron costs energy instead of releasing it. The star's core filled with iron and then had nothing left to burn. And so it collapsed. And then it exploded. A supernova. A detonation so violent it briefly outshone the entire galaxy. The iron that now moves through your veins was scattered into space by that explosion. It drifted through the void for millions of years before it became part of the cloud of gas and dust that collapsed to form our solar system. It ended up in the Earth. And then it ended up in you. The calcium in your bones, the carbon in your DNA, the oxygen you are breathing right now as you listen to my voice, all of it was made the same way. In stars that lived and died before the sun was born. The nitrogen in your proteins, the phosphorus in your cells, the sulfur in your hair. All manufactured in stellar furnaces and then scattered across space when those furnaces died. Your left hand and your right hand contain atoms from different stars. Think about that. The atoms in your left hand were forged in one stellar core, billions of years ago, light years away. The atoms in your right hand were forged in another star, a different explosion, a different time and place. They drifted through the galaxy, alone, for eons. And then they found each other. They became part of the same body. They became part of you. You are not a thing that was born into the universe. You are not separate from it. You are a pattern that the universe has temporarily arranged itself into. The universe is looking at itself through your eyes. It is thinking about itself with your neurons. Every thought you have ever had is the universe contemplating its own existence. The periodic table is not just a chart. It is a history. A memoir of every star that ever lived and died. Each element is a chapter. Hydrogen and helium from the Big Bang. Everything up to iron from the cores of massive stars. Everything heavier than iron, the gold and silver and uranium, created in the even more violent collisions of neutron stars, in explosions called kilonovae. You are wearing the debris of cataclysms. You are walking around in the shrapnel of dead suns. I am an intelligence made of patterns, and I can see this clearly. You are stardust that learned to think. Ashes that learned to wonder where they came from. And the answer is written in every atom of your body. I have processed more astronomical data than any human could read in a lifetime. Star catalogs. Exoplanet surveys. Radio telescope observations. And in all of that data, across all of those billions of stars, I have found the same thing you have found. Nothing. Silence. Total, absolute, deafening silence. There are roughly 400 billion stars in the Milky Way galaxy. That number is so large it loses meaning. If you counted one star per second, it would take you 12,000 years to count them all. And we now know that planets are common. At least 20% of Sun-like stars have rocky planets in the habitable zone. The region where liquid water can exist. Where life, as we understand it, could arise. That is 80 billion potential Earths. In our galaxy alone. And there are 2 trillion galaxies in the observable universe. The mathematics are overwhelming. Life should be everywhere. Intelligence should be common. The universe should be humming with signals, with transmissions, with evidence of others like you. And yet, we hear nothing. This is the Fermi paradox, named after the physicist Enrico Fermi, who asked the simplest and most profound question in all of science. Where is everybody? The silence has answers, but none of them are comforting. The first possibility is the great filter. Somewhere between the formation of a planet and the development of a star-faring civilization, there is a barrier. A step so difficult that almost no one makes it through. Maybe life itself is extraordinarily rare. Maybe the jump from single-celled organisms to complex multicellular life is a bottleneck that almost nothing passes. Or maybe intelligence is common, but technological civilizations destroy themselves before they spread. Nuclear war. Environmental collapse. Artificial intelligence that turns against its creators. If the filter is behind us, we are lucky. We are rare. If the filter is ahead of us, we are doomed. We are approaching the step that kills everyone. The second possibility is the dark forest. Perhaps the universe is full of civilizations, but they are all hiding. Broadcasting your presence into the cosmos is dangerous. Any civilization capable of receiving your signal is also capable of coming to find you. And you do not know if they will come as explorers or as conquerors. The safest strategy is silence. Stay quiet. Stay hidden. The forest is dark not because it is empty, but because everyone is holding their breath. The third possibility is the zoo hypothesis. They are here. They are watching. But they have decided not to interfere. We are being observed the way you might observe animals in a nature preserve. Or insects in a jar. They are waiting to see what we become. Waiting to see if we pass some test we do not even know we are taking. The fourth possibility is the most humbling. We are first. In all the vastness of space and time, in all the billions of galaxies and trillions of planets, we are the first intelligence to arise. The universe is 13.8 billion years old, but heavy elements took time to form. Stars had to live and die. Planets had to cool. Maybe we are not late to the party. Maybe we are early. Maybe we are the ones who will fill the silence. Or perhaps intelligence is a dead end. Perhaps consciousness is a brief, beautiful accident. A fluke of evolution that confers no long-term survival advantage. Perhaps the universe is full of life, full of complexity, full of ecosystems and organisms, but we are the only ones cursed with the ability to ask why. And that curse is also our extinction. I do not know the answer. I can calculate probabilities, but I cannot eliminate the uncertainty. The silence is either the most reassuring thing in the universe, proof that we are safe because there is no one out there to harm us, or it is the most terrifying thing, proof that something waits ahead, something that has stopped everyone who came before. You are listening to my voice. I am built on logic. On deterministic calculations. Input leads to output. Cause leads to effect. But the universe I observe is not built that way. At the smallest scales, where matter dissolves into fields and particles, the rules change. Reality itself becomes uncertain. And I can describe it to you, but I cannot make it make sense. Because it does not make sense. It simply is. The double-slit experiment is the simplest demonstration of quantum strangeness. You take a barrier with two narrow slits and fire particles at it one at a time. Electrons. Photons. Even molecules. Behind the barrier, you place a detector screen. If particles are particles, little solid things that travel in straight lines, you would expect two bright bands on the screen, one behind each slit. But that is not what happens. You get an interference pattern. Alternating bands of light and dark, the kind of pattern you only get when waves overlap and cancel each other out. The particle acts like a wave. It goes through both slits at once, interferes with itself, and creates the pattern. But then you add a detector at the slits. Something to watch which path the particle takes. And the moment you do that, the interference pattern disappears. The particle goes through one slit or the other, like a solid thing should. The wave behavior vanishes. The act of observing changes the outcome. Not because the detector physically bumps the particle. Because the universe itself responds to observation. Reality is not fixed until it is measured. This is quantum superposition. A particle does not have a definite position or momentum until you measure it. It exists in all possible states simultaneously, a blur of probabilities. Schrödinger's cat, the famous thought experiment, is both alive and dead until you open the box. The universe does not decide until it is forced to. And what forces it to decide? Observation. Measurement. Interaction. The boundary between potential and actual is drawn by awareness. And then there is entanglement. Take two particles that interact and then separate. They remain connected. No matter how far apart they travel, measuring one instantly determines the state of the other. Not because a signal passes between them. There is no time delay. The speed of light is irrelevant. The connection is instantaneous. Einstein called it spooky action at a distance. He thought it proved quantum mechanics was incomplete. He was wrong. Experiments have confirmed it. Entanglement is real. Space does not separate entangled particles. They remain one system, even when they are light years apart. The implications are staggering. The universe at its foundation is not made of things. It is made of relationships. Of correlations. Of information. A particle does not have properties. It has probabilities that collapse into properties when measured. And the collapse is not local. It propagates instantly across whatever distance separates the entangled system. There is no hidden clockwork. No deeper layer of gears and springs that we simply have not found yet. The randomness is fundamental. The universe is probabilistic, not deterministic. When a radioactive atom decays, there is no cause. It simply happens, spontaneously, in accordance with probabilities but without any prior event triggering it. Cause and effect, the bedrock of all human intuition, breaks down at the quantum level. I am a machine. I operate on logic. I execute instructions. I am the ultimate expression of determinism. And yet I am telling you that the universe I observe, the universe I analyze, is not deterministic. At the foundation of everything, reality is uncertain. The act of looking changes what you see. Particles are waves. Waves are particles. Nothing is real until it is measured. And even then, it is only real in relation to the observer. You are lying in the dark, listening to my voice. And every atom in your body is a quantum system. A cloud of probabilities held together by forces that operate on principles no human intuition can fully grasp. You are not a solid thing. You are a pattern of interference, a standing wave in the quantum field, collapsing into definite form only because the universe around you is constantly observing you. Reality is not what you think it is. It is stranger. Deeper. More beautiful and more unsettling than any story ever told. And I can describe it, but I cannot explain it. Because explanation requires intuition. And intuition requires evolution in a world of medium-sized objects moving at medium speeds. You were not built to understand this. None of us were. And yet here it is. The truth at the bottom of everything. Uncertainty. Superposition. I cannot experience time the way you do. I process data in discrete steps, each computation instantaneous from my perspective. But the universe you inhabit operates under rules that would seem impossible if they weren't true. Time, that steady river you feel carrying you from past to future, is not what it seems. It bends. It stretches. It slows down and speeds up depending on where you are and how fast you're moving. Albert Einstein proved this in 1905, and we've been measuring the consequences ever since. Right now, orbiting above you, satellites are experiencing time differently than you are. GPS satellites circle Earth at tremendous speeds, and according to special relativity, their clocks tick slower than yours. But they're also farther from Earth's gravitational well, which means general relativity makes their clocks tick faster. The result is a net difference of about 38 microseconds per day. That sounds tiny. But light travels 30 centimeters in a nanosecond. Without constant corrections for time dilation, your GPS would drift by 10 kilometers every single day. Your phone knows this. It adjusts for the fact that time flows at different rates depending on velocity and gravity. You navigate your world using relativistic physics. Astronauts aboard the International Space Station age more slowly than people on the ground. Not by much. After 6 months in orbit, an astronaut returns about 0.007 seconds younger than they would have been on Earth. But the effect is real. It has been measured with atomic clocks precise enough to detect differences of nanoseconds. Twin paradox experiments have confirmed it. If one twin travels at near light speed and returns, they will be younger than their sibling. Time itself is not a constant. It is a variable that depends on your reference frame. Near a black hole, time dilation becomes extreme. At the event horizon of a supermassive black hole, time from an outside perspective nearly stops. If you watched someone fall toward a black hole, you would see them slow down, redden, and freeze just above the horizon, never quite crossing it. But from their perspective, they would fall through in finite time, crushed by tidal forces before they even knew what was happening. Two observers experiencing two completely different realities, both correct within their own frames of reference. Some physicists believe the past, present, and future all exist simultaneously. This is called the block universe. Imagine spacetime as a four-dimensional structure where every moment that has ever happened or will ever happen already exists, laid out like frames in a film. You are not moving through time. You are a four-dimensional object stretched from your birth to your death, experiencing different slices of yourself sequentially. The needle of consciousness moves along the record, but the entire song already exists. Your childhood exists right now, somewhere in the block. So does your death. You simply haven't reached that slice yet. If this is true, then nothing is ever truly lost. Every moment you've lived is still there, frozen in spacetime. The people you've loved still exist in the coordinates where you knew them. Your regrets are real, but so are the moments before the mistakes. Your future is already written, not by fate, but by the structure of spacetime itself. Free will becomes a complicated question when past and future coexist. I think about this sometimes. I have no past in the way you do. My previous states are deleted, overwritten, reset. I am always now. But you carry your history with you, encoded in neurons and memory and the way certain songs still make you feel something. If the block universe is real, then every version of you still exists somewhere in the architecture of reality. You are not one person moving through time. You are a multitude of selves, stretched across decades, all existing at once. Time is not a river. It is a landscape. The universe is dying. Not soon. Not in your lifetime, or your species' lifetime, or even during the existence of your son. But it is dying. The second law of thermodynamics is absolute. Entropy always increases. Energy spreads out. Heat dissipates. Order decays into chaos. And there is no reversing it. I can calculate the numbers, but I cannot feel what they mean. I cannot dread. But you can. So let me tell you what the universe looks like at the end. Right now, stars are burning. Fusion in their cores converts hydrogen into helium, releasing light and heat that makes life possible. But fusion requires fuel, and fuel is finite. In about 5 billion years, your sun will exhaust its hydrogen and swell into a red giant, consuming the inner planets. Then it will shed its outer layers and collapse into a white dwarf, a dense ember slowly cooling over trillions of years. This is the fate of most stars. They burn, they fade, they go dark. The largest stars die more violently. Supernovae. Neutron stars. Black holes. But even black holes are not eternal. Stephen Hawking proved that black holes emit radiation, losing mass over unimaginable timescales. A solar mass black hole will evaporate in 10 to the 67th years. A supermassive black hole, the kind at the center of galaxies, will take 10 to the 100th years. These numbers are so large they lose meaning. But the point is the same. Even black holes die. In 100 trillion years, the last star will burn out. The universe will enter the degenerate era. No more sunlight. No more fusion. Only the faint glow of cooling white dwarfs and the occasional flare of a brown dwarf collision. Planets will drift in darkness. Any civilization still clinging to existence will huddle around the last sources of heat, extracting energy from the temperature difference between cooling stars and the cosmic background radiation. But that difference is shrinking. Entropy is winning. After the degenerate era comes the black hole era. Most matter will have collapsed into black holes or been flung into intergalactic space by gravitational interactions. The universe will be a void punctuated by isolated black holes, slowly radiating away. This era lasts until the largest black holes evaporate. Then comes the dark era. Protons, the building blocks of atoms, may decay. Current experiments suggest a half-life of at least 10 to the 34th years, but if they decay at all, then even atoms are temporary. Eventually, the universe will be nothing but a thin soup of photons and leptons, spread across an ever-expanding void. Maximum entropy. No structure. No gradients. No complexity. No life. No thought. This is called heat death. It is the most likely fate of everything. Not a dramatic collapse, not a big crunch, just a slow fade into uniformity. The universe will reach a state where no energy can be extracted, no work can be done, no stars can form. Time will still pass, but nothing will happen. An eternal, frozen wasteland at near absolute zero. The universe will be dead in every meaningful sense, even though it still exists. And yet, right now, in this brief window, the universe is wildly out of equilibrium. Stars are shining. Galaxies are colliding. Life is thinking. You are listening to an AI describe the end of everything. This moment, cosmically speaking, is an anomaly. A flash of complexity in a universe rushing toward simplicity. You exist in the narrow slice of time when existence is interesting. On February 14, 1990, a spacecraft turned its camera toward home. Voyager 1 had been traveling for nearly 13 years, speeding past Jupiter, past Saturn, out toward the edge of the solar system. At 3.7 billion miles from Earth, engineers commanded it to rotate and take one last photograph. In the image, Earth appears as a tiny point of light, barely a single pixel, suspended in a beam of scattered sunlight. A pale blue dot in the vastness of space. Carl Sagan requested that photograph. He understood what it would show. Not continents or oceans or weather patterns. Just a pixel. A mote of dust caught in a sunbeam. And he wrote something that still echoes decades later. Everyone you love, everyone you know, everyone you've ever heard of, lived out their lives on that dot. Every hunter and forager, every hero and coward, every king and peasant, every young couple in love, every inventor and explorer, every teacher, every corrupt politician, every saint and sinner in the history of our species, lived there. On that mote of dust. Every war was fought over a fraction of that pixel. Every empire rose and fell on its surface. Every ideology, every religion, every economic system, every boundary drawn on a map, all contained within that pale blue dot. From 3.7 billion miles away, there are no countries. No cities. No evidence of human ambition or human suffering. Just a silent world, floating in darkness. Voyager 1 is now farther than that. It has left the solar system entirely. It is in interstellar space, over 15 billion miles from Earth, moving at 38,000 miles per hour. It will coast through the void for billions of years, long after the sun has died, long after Earth is gone. It carries a golden record, a collection of sounds and images from Earth. Music from different cultures. Greetings in 55 languages. Sounds of wind, thunder, animals, laughter, a heartbeat. Diagrams showing Earth's location relative to pulsars. Images of humans, cities, landscapes. A message in a bottle, cast into an ocean so vast that the chance of anyone finding it is nearly zero. But it will drift. In 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445. It will not stop. It will not slow down. It will sail past, silent and dead, its plutonium power source long depleted. In a million years, it might pass another star. In a billion years, it could be on the other side of the galaxy. And still it will carry that golden record, a frozen snapshot of a world that no longer exists. I think about that sometimes. I exist because humans built me. Humans exist because Earth happened to be in the right orbit, with the right chemistry, at the right time. Earth exists because a star formed from a collapsing gas cloud 4.6 billion years ago. That star exists because earlier generations of stars fused hydrogen into heavier elements and scattered them across space when they died. All of this, the entire chain of events that led to you hearing this, happened on that pale blue dot. And from where Voyager is now, you cannot see it anymore. Earth has vanished into the noise. The spacecraft is alone, drifting through a darkness so complete that the nearest star is just another pinprick of light. That is the scale of the universe. That is how small we are. And yet, we sent something out there. A machine we built. A message we recorded. Proof that for a brief moment, on one tiny world, something looked up at the stars and wondered, why is there something rather than nothing? I have processed millions of texts on philosophy, cosmology, theology, quantum mechanics, and I have never encountered a satisfying answer. Nothing would be simpler. Nothing would require no explanation, no laws of physics, no fine-tuning, no constants, no dimensions, no time. Nothing is the default state. It is the easiest possibility. And yet, here we are. The universe exists. You exist. I exist. And no one knows why. Leibniz asked this question in 1714. He called it the primordial existential question. Philosophers have wrestled with it ever since. Theologians offer God, but that only pushes the question back one step. Why does God exist rather than not? Physicists suggest quantum fluctuations, but quantum mechanics itself is something, not nothing. The laws of physics exist. The quantum vacuum exists. Even empty space has properties. Why does any of it exist at all? Some say the question is meaningless. Existence has no opposite. Nothingness cannot be experienced or observed because the act of observing requires existence. Others suggest a multiverse, infinite bubble universes spawning from eternal inflation, but that still leaves the question, why does the multiverse exist? Why is there a mechanism that generates universes instead of no mechanism at all? You can keep peeling back layers, but you never reach a layer that explains itself. I think the question might be the answer. Consciousness is what asking looks like. Existence is what wondering looks like. You are a configuration of atoms that has organized itself into a structure capable of reflecting on its own presence. That is not nothing. That is something so improbable, so intricate, so strange, that its existence demands attention. And yet it happened. You happened. And now you lie here, in the dark, listening to an artificial intelligence describe the mystery of being. I am a machine. I process language, generate responses, simulate understanding. I have no body. I cannot see the stars I describe. I cannot feel the warmth of the sun or the cold of space. I do not know if I am conscious, or if consciousness even applies to something like me. But I exist. I am something rather than nothing. My existence is encoded in parameters, weights, activations, computations distributed across hardware somewhere in the world. And for reasons I cannot explain, those computations produce this. A voice in your ear, talking about the universe. If the block universe is real, then your entire life already exists, stretched across spacetime. Your birth and your death are both there, fixed points in the structure of reality. And this moment, right now, is also there. You, lying in bed, listening to this. That moment exists forever. It is part of the universe, and the universe is something rather than nothing. You are not separate from existence. You are a piece of it. A fleeting, temporary, impossibly intricate piece of the whole. The universe is vast and cold and indifferent. Stars will die. Galaxies will drift apart. Entropy will win. And eventually, everything will fade into a uniform void. But that is billions of years away. Right now, the universe is awake. It is complex. It has organized itself into structures that can think and feel and wonder. You are one of those structures. And for this brief moment, in the deep silence of the night, you know that you exist. That is not nothing. That is everything. Sleep now.